Everyone, welcome back to our channel, that is Chemical Engineering. Myself Dr. Kirti Zare. Today I am going to introduce you about the mass transfer, which is the very much important operation is going to carried out into the chemical sectors. There are different type of the applications of the mass transfer like the heat transfer. Basically, this is the base subject of the transport phenomena. The origin of this transport phenomena subject is going to happen combinedly into the heat transfer, mass transfer and the fluid mechanics. In my earlier video, I have uploaded the how can you calculate the mass concentration, molar concentration, density of the mixture, the what is exactly the mass transfer, what are the different means of the mass transfer, like the heat transfer. The heat transfer is nothing but there is a transferring of the temperature from the high to the low or low to the high. In the similarly manner, here also the main coefficient or the main separation factor become the concentrations. Right. So let us start for that particularly mass transfer operation or what is exactly the mass transfer operations. Right. So the mass transfer is nothing but there is a different components within a one system which can be drawn or the separated by its concentration gradient, by its concentration gradient or by any external means of the forces. It also involving the one location to the another locations. In that you can suppose to use the different type of the phases such as the liquid, solid or the gases. The mass transfer, it is the movement of the substance from the one place to the another place. It is generally created due to the concentration difference. These concepts you are supposed to use into the many sectors in the chemical reactors. It can be also used in our domestic purpose like for the cooking. In that definitely mass is going to the transfer and also the different environmental science. The means of the physical origin of this particularly mass transfer which is generally including with the diffusion, convection and the change of the phases. So these are the different three ways. Like in the heat transfer, the temperature gradient is the important factor, and apart from that there are the different three modes of the heat transfer. That is nothing but the convection, conduction and the exactly happen into the diffusion, right? So diffusion is the always transferring of the high concentration to the low concentration region. So at that time there is a movement of this particularly molecules at the random, right? Through this concentration the molecules movement is the transfer, but it can be transferred uniformly through that particularly place from the high to the lower concentration, right? If you are going to take the simple example for the preparations of the examples of the mass transfer through the diffusion, which can be including the solutions for the pure water in the reverse osmotic principles. It can be in that if you are going to add the some water molecules, so initially it having the high concentration, but as the movement of this particularly concentration is going to occur, so it is get converted into the low concentration. So again the most important factor is that it must be achieving the 100% molecules at the end. That is called as the equilibrium at the steady state condition. That is again very much important into the diffusion, right? Diffusion, right? So always diffusion is occur from the high concentration to the low concentration. So whereas the main principle is going to involving that is the Fick's law, right? So in the diffusion you are supposed to use the Fick's law. Like in the heat transfer, temperature is the main factor, and with respect to that conduction, convection and the radiation, right? So with respect to these modes of the heat transfer, they are going to use the different laws like Fourier's law, Stephen-Boltzmann law, Wien's displacement law, Kirchhoff law, right? So these are the different laws is going to involving into the heat transfer. In the same manner, in the mass transfer, there is a Fick's law state as the J is equal to the minus DAB into the rho C by the rho x. Diffusion coefficient, right, of the mass transfer, this negative sign is indicate there is a transferring of the molecules from the high concentration to the low concentration. So if you are going to consider this DAB, so there is a transferring of the molecules from the A to the B, and this is nothing but the concentration gradient in which DC is the concentration and the dx is called as a distance. Sometimes you can also consider in the form of the thickness as well, right? So this total term is called as a concentration gradient. Whereas in the heat transfer, we are supposed to use this in the terms in the temperature gradient, right? So this is the basic principles with respect to the diffusion, and that is the main fundamental of the mass transfer operations of this particularly form of the diffusion, that is nothing but the convection. Here you are also used the same phenomena like you are used into the heat transfer, like it can be occur into the naturally or it is occur by the forcefully, right? So whenever you are going to talk about the mass transferring, so mainly it can be involving into the surface. There is a transferring of the molecules from the surface which can be moved from the towards the second place. It also, you can also take on the miscible or immiscible fluids over there. So best example of that, if you are going to consider the evaporation of the water, if you want to remove the moisture, so by you can use the fans at that condition, or maybe it can be also occur the naturally. The next means of the mass transfer, that is nothing but the phase change. So what is exactly happen in that the phase change? Its name is indicate that change in the phase which can be transferred from the solid to the liquid, liquid to the gas, gas to the solid, or the vice versa, right? So definitely there is a changes in terms of the phases is occur. The examples of this, like condensation is there, evaporation process is there, melting process is there. It can be also used into the different transferring of the phases is going to the of the mass transfer as well, which can be including mainly into the distillation column, in the packed column, in the membrane separation. It can be also used into the leaching, absorption, adsorption, fertilization, fermentation, crystallization, heat exchanger, and so on. So these are the different applications and the brief about what is exactly mass transfer operation, right? In my previous video, I have uploaded that how can you solve or how can you calculate this molar concentration, again mass concentration, again the density of a particularly binary mixture. Here also by using the diffusion law, you are supposed to calculate the diffusion coefficients over there. Numericals, which is stated that you are supposed to calculate the diffusion coefficients for CO2 in O2 at 127 degrees centigrade, and the temperature they are given 1.1 into 10 raised to 5 kPa pressure by the given data. So they are given the molecular volume of the CO2 is 34 centimeter cube per gram mole, and same manner for the molecular volume of the O2, that is the stated as 7.4 centimeter cube per gram into the mole, right? Now we are supposed to find out that how much diffusion is going to occur over there. So there are the different type of the equation are going to used for calculating of this particularly form of the diffusion. To 437.5 T, that is the 3 by 2 into bracket P VA, that is the 1 by 3 plus VB, that is the 1 by 3 whole raised to the square, multiply by the 1 MA plus 1 MB whole raised to the 1 by 2, right? Right? Now, what is the, now T is the given, pressure is also given, VA is nothing but the molar volume of the A. So here the diffusion is occur with the CO2 to the O2, right? So here you are going to consider the A as the CO2 and B as the O2, right? So you are supposed to consider here the molar volume of the CO2 and the molar volume of the O2. And here you are supposed to consider the molecular weight of the CO2 and molecular weight of the O2. So let us put this all value over there. That is nothing but the 437.5 T. So that is the 127 degree centigrade. 127 degree centigrade. So you are supposed to convert into the degree Kelvin. So that is become the 400 Kelvin. That you have to add the 273.15, right? So you are going to put that is the 400 divided by the pressure is also given, that is 1.1 into 10 raised to the 5 multiplied by the VA. So that is become the 34 raised to the 1 by 3 plus 7.4 1 by 3 into bracket 1 upon the 44 plus 1 upon the 32 whole raised to the 1 by 2. So we are getting the diffusion become the 0.2735 centimeter cube per the second. So this is the diffusion is going to occur from the high concentration to the low concentration. This particularly form of the numerical. So please subscribe my channel, that is chemical engineering. Please share it, comment it. Thank you so much for the watching.